Right, let's start off with our first revision activity. Remember, these we're going to be working through the sheet we've been given in class, okay, and it's just to help you to structure revision and make sure you're remembering the most important stuff. So, energy can be defined as the ability to do work. Now, what we mean by that is work is causing a change in something. So that could be making a light bulb light the room, or it could be moving from place to place. By moving stuff, you need energy, and we call that work. And we need energy to cause all these changes. So that's what we mean by energy is the ability to do work. It's the ability to do stuff. Now, there are 8 different types of energy. Kinetic is our first type, which is all about movement. Moving objects, how they move. The faster they move, the more kinetic energy they've got. Gravitational potential energy is all about their height above the ground. The higher they are above the ground, the more gravitational potential energy they have. This one is chemical. So anything involves chemical reactions is going to have chemical energy stored in it. So for example, food. When you digest food, chemical reactions take place. So there's chemical energy in food. There's chemical energy in batteries because there are chemical reactions that take place in batteries when you use them. And there are chemical reactions which takes place when we burn fuel. It's important to remember it's only fuels that we burn contain chemical energy. There are nuclear fuels which contain nuclear energy, which we're going to put here. Sun, as the sun is an example of that. Then we've got elastic potential energy. That's where we extend an object or stretch an object and it returns to its original shape when you've removed the force from it. Okay, we all know that if we extend an elastic band and we let go, it hurts our hand. Okay, and that's to do with the energy stored in the elastic. Then we've got magnetic, which is obvious, associated with magnetic objects. We've got electrostatic, which is associated with charged objects. So when we jump up and down on a trampoline, we can sometimes charge our bodies up, and then when we step off it and touch something else, we get a shock. That's due to a difference in charge. And then finally, we've got thermal. Okay, so thermal energy is associated with temperature. The hotter something is, or the higher the temperature, the more thermal energy it's got. Now, straight on to conservation of energy. Now, conservation energy means keep the same. So what I've done is I've divided this box into 2 sections, and it's to show a closed system. So a closed system is just an area where nothing on the outside of the system can affect what's going inside, and nothing on the inside can escape out of that system. So let's say we've got someone throwing a ball up into the air. Okay, that ball goes up in this direction, okay, and it gets to the top and it pauses in midair for a fraction of a second, because that's what happens before it comes back down. It pauses and it comes back down to earth in that way. Now, what we've got is as the ball gets higher, the gravitational potential energy of the ball increases, because I don't know why I did a Y there, that's an arrow. Okay, the gravitational potential energy of the ball increases. That's because the height of the ball increases. And the kinetic energy of the ball decreases because as you let go of the ball, gravity is pulling down on the ball and slowing it down until eventually it stops, and then it comes back down again. So as it comes back down, the gravitational potential energy decreases because its height's getting lower, but its kinetic energy increases because it starts to accelerate, it starts to get faster due to gravity. Okay, so its kinetic energy increases. Now, the important thing to remember here is the amount of energy overall always remains the same. Okay, and we call this conservation of energy. So at this point, if we had 100 joules of gravitational potential energy and 0 joules of kinetic because it wasn't moving, by the time it gets to the bottom, that's going to swap round, because it's just before it hits the ground, it's going to have 0 joules of gravitational potential energy because it's got no height, but it's moving at its fastest, so it's got 100 joules of kinetic. Now if we add 0 and 100 together, that gives us a total of 100, and we add 0 and 100 together here, it gives us a total of 100. So the total amount of energy in the system always remains the same. That is what we call conservation of energy. Now there will be some extra energy going on in here in real life, because as the ball moves through the air, friction, okay, causes a bit of that kinetic energy to transferred into thermal. So what you'll notice is that kinetic energy will start to get smaller and smaller as more of that thermal energy is, or more of that kinetic energy is transferred into thermal, and then that thermal energy dissipates into the atmosphere. Let's have a look at some examples of what we will see in our exam papers. So what we've got here is a hot tub that's heated by burning some wood. Okay, now whenever you're unsure about what to write about, the diagrams are often a prompt. So if we look at the diagram, we've got some wood, we've got a pipe, and we've got some water. So usually that means we're going to have to talk about those things. Luckily with this question it's prompted us. So the wood, we know the wood is a type of fuel, and when we burn something it's got chemical energy, and we know the chemical energy of the wood decreases because we're burning it. Okay, and that's what we have to say. We have to say the chemical energy of the wood decreases. All right. Now, as we burn it, we know that the thermal energy is going to be released, and some of that thermal energy is going to be transferred to the pipe. So we say thermal energy of pipe increases. Okay, so you can see we've got that pattern. One type of energy store decreases, another type of energy store increases. And then finally we've got water. Okay, so the water is flowing through the pipe, so the thermal energy within the water, energy store of water increases. But we must remember overall the total amount of energy must stay the same. So the chemical energy of the wood decreases because we're burning it. Once we burnt something, it turns to ashes. We can't continue to burn it because it's got no energy stored within it. So that decreases, and thermal energy of the pipe increases, and thermal energy stored of the water increases. This is how we have to answer these questions. It's really important we answer them like this. We don't answer them in any other way. Here is another example. Now, you can write your answer in the space below, but I'm just going to annotate the diagram. It makes it easier. So we've got fuel here. In this fuel, we can see we're burning it. So if we're burning it, it's to do with about chemical energy. Okay, and we know the chemical energy is going to decrease. So we can say chemical energy decreases. Again, we're using the diagram to help us to structure our answer. So we've got fuel to talk about, we've got water to talk about, and we've got gas. So we know the chemical energy of the fuel decreases. We know that flames release thermal energy, so the thermal energy of the water is going to increase. Sorry, so thermal energy increases, and we also know that not all the thermal energy is going to go into the water. Some of it's going to be transferred into the gas. So if this wasn't lit, the gas would be a lot cooler, a lower temperature. So the fuel from burning it causes the gas, the thermal energy of the gas to increase. So thermal energy of the gas increases. So in our space below, we can say the chemical energy of the fuel from burning decreases, the thermal energy in the hot water increases, and the thermal energy in the hot gas increases. Again, using the diagram to help us structure our answer. And that's it for part one. Thank you.